So this looks all right, not too bad. But there's a few things that we should probably look at. First thing is that the width and the height is not square. The ratio here is actually 28 to 38. This is a pretty normal ratio compared to some of the exports I've seen. I've seen numbers where it's been like in the 30,000 to 20,000 something ratio. The next thing is we have this translate. So this translate here is going to offset our x position by a -5 and our y position by -2. Okay, so, all right, so what does this get us? So if we actually import this into Android Studio, we get this icon here. Okay, it doesn't quite look like what we had. So if we compare it to what we had in Sketch, we can see that the icon is a little bit wider. So what's going on here? What's happening to our icon? So let's just dig into it a bit more. So let's compare our SVG and our vector drawable to see if there's anything that's changed from when we exported it to when we've imported it. So our view box is the same. The view box is also called the virtual space, and it's the positioning that all your path data will be drawn inside. The actual width and height is separate to this, and we'll get to that in a second. So, and here we see something that kind of gives us a bit of an idea about what's going wrong here. The size in our SVG is 14 by 19. The size in our vector drawable is 24 by 24. And that translate has disappeared. When importing into Android Studio, the translates are actually inlined. So any kind of transformation that's been applied to the path data will now actually be inlined into that virtual path data. So why is the width and the height after we've imported into Android Studio 24 by 24? So there's one thing that we can do here, and that is to override what Android Studio is importing. Now, this is pretty simple. We just click the little box that says override. And once we've done that, our width and the height becomes the same, and our viewport becomes the same. But there's something not quite right with this picture. And the problems start to show up when we keep overriding all the vector drawables. So let's import another one. Let's import our next icon here, which is this kind of replay arrow here. So our width and our height is different, and our viewport is different. And this starts to become a bit of a problem if you use it when you're looking at the width and the height. So if we look at the width and the height of both our images here, we can see that the width on from one vector drawable to the next is not going to be consistent. Now, if we're using wrap content in our layouts, we will start to see where this can become a bit of a problem. So here I've got my top icon as being 48 by 48, and then the next two I've wrapped content. The size in the vector drawable that we import into Android Studio defines what's called the intrinsic size. And this is the size that the vector drawable will default to unless you provide it something in your XML layout. The next thing to look at is our viewport. So if the intrinsic size is the default size that we specify, or in the layout is the size, then how does the viewport become matched? Because the viewport is the coordinate system that we're drawing our vector drawable in. And the way in which this works is that the viewport will scale the path data to match either the default intrinsic size or the intrinsic size that we provide in our layout. So in this case, if I say that my icon is, I talked about that. Sorry. Now, the other problem that we run into when we're having to deal with this viewport, sorry, I forgot, and the intrinsic size is that we start to lose things like the internal padding in our image. So because that's what that translate was. That translate is when you're exporting out a sketch, it is the offsets that the image is going to be in. So when you're exporting it, those offsets for the intrinsic padding is going to be then inlined into your image. So your alignment starts to get a bit off. And we can get non-symmetric shapes, and it becomes really hard to kind of get everything to fit nicely in a consistent manner. So how can we ourselves, or how can our designers export in a more consistent manner? So if we go back to, in this case, Sketch, we want to select the artboard. And the artboard is the big white thing behind our icon. This will mean that any kind of intrinsic padding we have inside the image that we want to preserve, which will also mean that doing things like alignment will be preserved when we're trying to inflate the image to much larger sizes, will be exported. So in Sketch, often you'll find that the artboards use the symbols, so it's the symbol that you want to be exporting. And that's what you want your designers to export. Now, ideally, you want to have the artboards be consistent size, because if the artboards are inconsistent in the size, we'll have the same problems that we saw before. So now if we export our icon, we can see in our previewer or import that the icon is not so wide anymore. And everything is now 24 by 24. Our virtual space where we're drawing our path is 24 by 24, and our default intrinsic size is going to be the default that we want. One issue that you run into, especially, well, a common practice, I should say, when designers, when using Illustrator, is to have a single artboard of multiple assets. And this goes back to the fact that Illustrator historically would only allow you to have maybe about 100 artboards. Now, I think this was a bug. This Adobe have since fixed. So if this is a complaint that your designers come back with, oh, we can't have more than 100 artboards, you can. Adobe has fixed this now. But we get the problem of when we export, we don't know what the bounds of that intrinsic padding internally to the image should be. So if your designers are using a mono artboard for all the assets, we need to be able to give the export context as to the bounds between where the image actually ends and where the icon padding is located. So in this case, we can just put a box around the export and then export the box and the icon as a group. Don't put the icon inside the box. This is a mistake that I kind of made a few times. It changes the layering, and it will export with those translations again because there is no bounding context for it to be able to refer to. And now a question that always annoyed me for ages and ages and ages was why 24 by 24? So I asked a few people and asked people at Google, and this is the answer I got. It's a nice multiple 8. That's it. There's nothing magic to it. But the 24 by 24, I think, is a good consistent size and a good number because it's the standard definition for what an icon is. So normally you would have an icon that is 24 by 24 point, and then you would put it inside, if it's something which can be touched, in the touch area of 48 by 48. So the icon is usually about roughly half of what your touch area will be. The next problem that you'll run into a little bit is the path size. So the path size in Android ideally wants to be as short as possible, and you want to have as few paths as possible. And some of the problems that you can have in being able to create a smaller path size is the way in which your designers may be creating assets. So this little plain icon here, we can see that the designer has created it by drawing the shape, and then they have outlined the shape. So the vector paths actually go around all the exterior of the plane here. Now, this adds a lot of what are called anchor points, and these are the points at which the line draw and the arcs originate from and move between. So if we look at our little plane here, when we export it, we see something like this. Not exactly the smallest, most simplest thing. Like, you'd think the plane like this would be a little bit simpler. So the answer to this problem is that we can just optimize everything. Like, we're developers, we can always optimize. So the path data we saw before was 4,800 characters long. They had 6 decimal precision, and really, your phone isn't as big as the screen we have here, so you don't have the eyes of a hawk. So if you're not familiar, hawks have the ability to actually telescopically zoom. Now, I don't think you have this, or at least I don't. Even my glasses don't have this feature. So what can we do about this? Well, the first thing we can do is we can use tools like SVGO, and this is an SVG optimization tool. So before we import into Android Studio, we can run the SVG optimizer over the tool. Now, for the most part, most of the defaults in SVO are going to do the things that you want. If you want to get really deep into it, you can turn on a bunch of different features, but I would recommend just starting with using 2-point precision. 2-point precision will give you pretty much the degree of fidelity that your images are going to work with. And Google does recommend that you don't use SVGs on icons bigger than 200 by 200. So any imperfections you're going to find on the edges of the images, assuming that you're exporting them correctly, is not going to be noticeable to the human eye. So after running the optimizer, we can actually kind of read this now. So that's good. But our path is still too long. It's still almost 1,200 characters. And the way in which we can cut this down is by using a different drawing technique. So in this case, we're going to draw the plane using what I believe are called stroked paths. And that is to say, we're just going to use an Illustrator, it's called the pen tool, and we're just going to draw the path. So the path is going to be usually 1 point wide, and we can tell the path that we want to have the capped ends. And this will allow us to have those rounded ends on the edge of our path without having to manually kind of add those extra paths into our drawable. Now, this can be kind of a little bit tricky to get to. A common technique is to compose shapes by intersecting with each other or using a mask. Masks aren't supported in vector drawables, so if your designers are trying to use masks in your design, it's not going to work. They're going to have to find another way to express the image. And if they really do want to have that mask, then you're just going to have to export it as a PNG. So if we change the plane to use stroked paths, we now get a much more smaller vector drawable. We have a lot of paths because the path data that we had, the paths don't always intersect. So they have to start at different points. And we don't have a nice way to kind of close the circle. So if you're drawing a box, you can kind of draw 3/4 of the box and then tell the tool to then close the path, and it will draw a direct line between the last point and the beginning of the vector drawable. So let's assume that we've imported this into our project. Now, is there anything more that we can do here? And there actually is. So I've found the tool called Avocado can sometimes do a little bit more than what SVGO will do. And in this case, what it's going to allow us to do is reduce our path by, I think, about 100 characters. Sorry, 30 characters. Sometimes it can be better. And we've also reduced the number of paths that we have. So before we had 5 paths, and now we only actually have 4. So the number of drawing instructions we have has been reduced by 1/5. Now let's talk about cache, my favorite topic. So in this case, we're just going to draw the microphone icon 3 times. No tinting, no nothing, just draw it 3 times. And so if we log out what's happening, we can see that the onDraw has been called 6 times. This might be because I used a bad layout. But we can see that the cache is missing on the first 2 times it tries to draw. But every other time since then, it's hitting the cache. I'm not entirely sure why I'm drawing twice, but that's the case. But what happens if I apply tint? Now, the Android documentation says that the vector drawable should hit the cache as long as the size is different. But we're not. We're missing the cache. Something is happening, and we keep missing the cache. No matter how many times I draw this icon, I will always miss the cache. So if we dig into the vector drawable code, we can start to get a bit of an idea what's going on. So there's this function called can reuse cache. Okay, so let's have a look at that. So it turns out there's actually a few more criteria for being able to reuse a cache than what the Google documentation says. And if you go through the vector drawable class, you'll find a lot of comments in there which aren't mentioned anywhere in the documentation. So the support vector drawable is fairly similar, but we can start to get a bit more of an idea about what's happening. So the support vector drawable is a nice class to dig into because it has to emulate a bunch of the native functionality. So we can get a better idea about what's happening underneath the hood. So in this case, we want to have a look at our create cache bitmap if needed. And in there, we can see that there is another parameter which is checking to see the height